Hey, I just want to make a quick video going over the dynamic global illumination system that I showed briefly in a video last week. There are two different lighting systems I wanted to show in this video. The first is the one I showed last week, which was the localized dynamic global illumination system, which basically allows you to get either a dynamic or more static version of global illumination in your scene with very good performance. Since there's no point lights, no dynamic lighting used with this system, no additional ones I should say, there's a directional light, but since there's no additional lights, the performance of this is extremely good. Now you'll see the frame rate up here, but that's not really accurate. If I hop in game, you will see the frame rate is actually quite high in game. I usually max out at 120 for this scene. So let's turn on stat FPS. So you see the frame rate is extremely high in game. You can see some of the lighting, you get a little bit of the blue from the tarps here, you get like some red there. You got the light bouncing off the sand and off the actual environment. And hop back in editor here. Show what it looks like without any bounce lighting. This is what the scene looks like with just regular default Unreal Engine 4 lighting. And this is with it turned on. So basically, I wanted to say what this is and isn't so I don't get any false ideas as to exactly what the system can do. I call this a localized system because you can only use this in small areas. You can only use it, I guess, localized. You can't. It won't cover your entire world. It won't cover every inch of the map. It's only meant to give some global illumination in specific areas. Overall, like I said, the performance is very good since it's not using any lighting. It's actually done through post-processing. I can show a little bit of the technical side of this now. The actual lights, let me open up the blueprint for this. Just to show kind of under the hood exactly what this is doing. So to start off, let me see if I can get the options here. Here we go. So what this is basically doing is getting several traces. I think right now for this system here, there's 13 traces, but you could very easily go up several more just to increase the overall quality. But at 13 traces, as you saw before, I still have pretty much perfect performance. It doesn't really affect it a whole lot. So this does 13 traces. There's like an inner cone and a outer cone, just to kind of visualize where it's doing the traces. So it traces around the circle. You can decrease it, increase it, and it will basically trace based on the distance you have set up and the actual cone radius. And you can also control things like how much the bounce lighting affects things. You can change, say, the desaturation of the bounce lighting, have no saturation from bounce lighting at all, or extreme bounce lighting. So basically, after you do the traces, I can show, I'm actually going to turn on the traces just so you can kind of see just a visualization of what it looks like. This is the actual trace function, where it's basically getting the different points, getting all the values in. turn on the visualization. This is going to make my light captures all red, as you can see here, but just to see kind of how the traces and where it's getting the points and stuff and how that works. So you can see it's doing traces based on the radius of that inner cone and outer cone. And wherever this is facing, it's basically is where it will put the points for global illumination at. So basically, based on an inner and outer cone, you will get a trace, and at that trace I have pointing different render captures, the 2D render captures. You can see here there's 13 of them. As I said before, you can scale that up or down based on your needs. If you wanted to add a lot more detail, you could increase this tremendously. But this doesn't really hurt performance very much because I'm only capturing these at a field of view of 1, and for the actual textures it's capturing, see here, these are the actual colors that it's capturing. It's only capturing each texture at 1, a scale of 1 and 1. So it's not going to add a whole lot of memory, and since it's capturing at such a low resolution, it doesn't really hurt performance much. It doesn't take much to do. It doesn't hurt memory very much. I also have it set up so it captures only 10 times a second, just for performance reasons. You can't really tell from looking at this that, oh, let me turn back the real-time setting. But you can't really tell by looking at the actual lighting that it's only doing it 10 times a second, so it doesn't really matter. It's just more of a performance thing. So yeah, you can't really tell. It's not like blocky or anything. You'd probably increase this to doing it maybe once or 5 times a second or something, and it wouldn't be that noticeable if you needed more performance. But you can see the actual global illumination. If I make this wiggle a little bit, see it updating the lighting on the wall from this. And again, you can increase or decrease the actual effect it has. Get a little wiggle in there. So again, this is a pretty limited system overall, but it really gets the job done for things like I'll probably be using in a lot of my future scenes that I do. It's also very useful for like much more enclosed areas. And again, it is just localized, so you're not going to have this system working on a giant open world environment or anything. But it still, as you can see, works pretty good for what it is. And again, just disabling it, this is basically what it would look like with it off. So there's a few more things at a technical level to get it looking as good as it does. It's not simply doing a trace, doing the render captures, and putting it through the post-process volume. I'll actually have to open up the material for that just to show kind of how the material works for this. It's one of the more complicated parts of the system. So basically, the blueprint for this does a number of things. It first goes through, finds out what direction it needs to place different points at, based on like the cone width, the radius, all of those things. And say if you have this pointing like straight up in the air, so it's hitting nothing, then it basically phases those points out and stops capturing for them. So it's kind of an optimization thing, and it also makes it where it's not putting weird lights in random places. So also, upon doing the points, finding the points you trace to, Then you do the actual trace. And based on that, it comes up with a whole lot of different information that it passes through to the material parameter collection, which is all accessed through the actual post-process material. And if I go into the actual material, I'll just phase out some of the stuff here so you can actually visualize kind of how this is done. I'm using sphere masks placed at a world position. So once you get the trace in the blueprint, that basically gives you an exact point in the world, which is passed into the post-process material, which I put in as a world position. So you can see like here, there's like light position 1, 2, 3. And then with the sphere masks, it puts in that location at world position. With the light radius, which is also done through the blueprint and is based off of several different things mathematically in there. So yeah, this gets you the world point. Let me plug this in just so you can kind of visualize the different steps that this goes through. So if I remove all of that, then you'll see, like, this is just showing one single point. So I guess this is taking the one to its right there. It gets the point in there. This has no detail, it has no directionality. So the next step for this to make it look better, I get directionality so it's not affecting back faces and stuff. And also to allow it to get ambient occlusion values, and it also gets roughness values. So I'd get that through here. You can actually get the roughness and ambient occlusion, and it also gets the world normals. So I'll show what that looks like, just to, again, visualize kind of what it looks like with just those things enabled. So whenever you add all of those things up, this is with the ambient occlusion, and you can see the normals that it's actually adding into it. And this system I have not updated like I did with the light probe system. You do have some of the back faces still being lit a little bit, just because I didn't have some of the material stuff set up correctly, but I believe I set that to 0. Yeah, so now you can see that it is only lighting the faces that are directly facing that point, that is wherever that point ends up at. So if I put that, like, rotate it up on the roof or something, it's only going to light up the faces that are directly facing towards that capture point. And this is done for every single trace point, all 13 of them. And it basically uses these values to plug into the linear interpolation, which allows you to put this point in with the capture light and the scene capture and everything that gets. So whenever you add all of those all together, you would get the final result that was shown before. Ooh, I did that wrong. Oops. Yeah, so what you end up getting from that is actually a pretty believable bounced lighting that actually has directionality. It takes the world normals into it all, so it looks pretty good in the end. Change this back to right values. One of the other nice things about this system is that it can be captured statically or dynamically. Like right now, this is completely static in its captures. It doesn't have to continually capture points to render in the world. So if you wanted just the post-processing side of this, but you don't need it updated in real time, like this environment doesn't have a day and night system, so there's no reason that this would need to be updated every single frame or even 10 times a second. So basically, as you can see right here, this is with it being statically rendered. It's not going to be updated every system. Basically, it just takes whatever the last input was and it keeps it that way persistently. So the post-processing side of this is not all that expensive. I believe the most expensive part by far is doing the actual updating, doing the captures 10 times a second, because you're basically, even though you're capturing textures that are only 1 by 1, which are very small, that's still 13 of those 10 times a second. And even though it still doesn't really hurt performance, it is the most expensive part of the system. So if you do not need a system that is updating, that doesn't change, it's just an environment like this with no day-night cycle, you can remove the most expensive part of that by far and just have it a static system, which is what you're looking at right now. It will look exactly the same. The only thing is if you take the directional light or something and update it, you'll see like the lights are still there exactly. But for most things, like the scenes that I'll be doing in the future and stuff, they probably would never need to be lit dynamically. So for performance reasons, it's great to have the option to have it just kind of remain there like this. So that's definitely another option for people if you wanted to have something like this working in mobile, say, it would probably run perfectly fine. So the nice thing about having it all done through scene captures is it is fully dynamic. So it doesn't matter what you're putting in front of the cameras, it will always give you a somewhat appropriate color change. So let's hop and simulate here. I mean, as you saw before with the flag, you can change, you start messing around with it, it'll actually bounce the lighting a bit more. Let's get the directional light though. There we go. You can see it's actually updating with the light changes. And it doesn't matter, like if I change the directional light to a blue color, it'll still reflect the lighting as blue because it's capturing what the cameras are looking at. So it doesn't matter if you have a day-night cycle or whatever it is, it's going to still capture whatever colors or darkness values or whatever you have it looking at, because it's still basing the light bounces off of what's actually in the world. So it's pretty versatile. So yeah, that pretty much covers it for the global illumination system. I just wanted to cover quickly the ideas I had behind it and kind of the directions I took with it. There were a lot of difficulties I had in getting this to work, but a lot of the things came together a lot better than I thought, like getting directionality from the bounce lighting so you can see it's actually affecting the normals properly. It will work correctly with things like roughness values that you have in the environment. There are a few issues still that I don't believe I can fix, like light bleeding. It won't cast shadows, the bounce lights won't. You could technically add multiple light bounces, that would be extremely easy to do. But yeah, the light will bleed through objects. even though it won't light the back faces incorrectly. But it is a little limited, and it is only really good for very localized situations, basically. But for what it is, as just a fun experiment, it is still a lot of fun to play around with, and it works quite well for what it does. But yeah, that pretty much covers it for the localized global illumination system. I also wanted to show another system that I think I'm a little bit more excited about, just because its real world use I think is a lot more interesting. I think it's a lot more useful overall. And that was basically a light probe system that I created. It's using the same concept overall as to using the post-processing materials to get the lighting. But for this system, it's basically more of a replacement for point lights. Basically, you can make these actors and you can change the color of them to anything you want, just like a point light. You can change their radius, change the fall off, change the brightness, like everything works just like a regular point light for the most part. It also has directionality, just like a regular point light does. They don't cast shadows, which is their biggest limitation still. And I don't believe there's anything I can do about that, since it is just a post-process volume. It would be quite difficult to do, I believe. But they still work with things like roughness values. They have the light directionality, like I mentioned. They will affect normals properly. Let's set the brightness down a little bit. So they actually affect normals just like an actual point light does. The best thing about these, though, is they don't have some of the limitations performance-wise that a lot of point lights do in Unreal Engine 4. You could stack all 16 of these. I say 16 because right now the system's only built for 16 point lights, but you could easily scale that up to probably well over 100. These don't use any scene captures at all, like the global illumination system I showed. These are more just meant to be kind of a replacement for point lights. But like I said, you could stack all of these in one single location or spread across a huge area. I don't believe it matters how many different objects the light touches. It doesn't matter how many you have stacked at a single location. The post-process material has just a flat cost, so it doesn't matter where they are, how much of the objects they're touching. The performance cost for it should remain the same, so you don't have the limitations like you do with Unreal Engine 4, where you get a lot of point lights in an area and it starts to affect performance a lot. So again, it works just like the global illumination system for the most part, but these are more of a manual approach. When I'm making environments, especially dynamically lit environments, I usually like to go through and place point lights manually, just add and kind of fake some bounce lighting, since you don't get that with dynamic lighting. So this will basically allow me to do that without much of a performance cost at all. There are no scene captures or anything. This system is extremely cheap on performance. And since it does work just like point light, for the most part, there are a couple little limitations, I think, in terms of the quality of them versus point lights, but as you can see, they do look pretty good. You won't really notice anything huge that in terms of the way they work over point lights, it's mostly the same since it's doing directionality. It even takes into effect like the AO, ambient occlusion, normal directionality, roughness, so it gets a lot of the things that point lights do, and it doesn't like override any of that. You can use it directly with point lights, you can use them to blend them together. But this is just again, I use this scene just for small reasons, just a quick scene to use this for testing, but as you can see, we turn them all off. So this is what it looks like, again, without any of the probe lights. This is just default Unreal Engine 4 lighting with a directional light and skylight. And this was just like a real fast, dirty pass I did using them. And just like point lights, you can also see the color that the lighting is. So you can tell I use kind of a bluish light there. I tinted it kind of blue and reddish kind of. I set up like a custom material, so basically takes whatever light color you change it to and changes the actual icon to be that color as well, just to help you visualize it. But I also, just to show it in more of like a final setting, or more real life setting, I have been working on a level for a while, and I'll probably release a video of this at some point, but here is a situation with a very large environment. I haven't placed the light probes through this or anything, but there is one right here. You can see it bouncing the lighting onto the cliff, or it's like it's faking light bounce to the cliff. Again, that's just default lighting, and this would be with the light probe in there, getting a little bit of the light bounce, but these are very easy to work with, just like with point lights. If you just want to go in and fake some global illumination using point lights, it's exactly the same thing. So if I say like this area over here, I'd want to get some nice fake bounce lighting in there. Just get another one of these guys in here. Say 12,000 is a little too much. You just add a light in there, maybe get a little bit more. And there you go. It's just like adding a point light, but without the cost of a point light. And you can place these all over the environment and get some really nice faked bounce lighting in here for extremely low cost. And since they work like point lights, it's not like you have a learning curve or anything if you're used to going through your environment and placing some actual lights, just point lights and stuff. This will feel very natural to you. They have the settings of like a regular point light for the most part, just at a basic level. But yeah, it's a pretty scalable system. Like I said, I think this is a lot more useful overall than the localized one. The localized one's cool, and if you have some indoor scenes, like closed-in areas, then that system will work very well for you. But something like this, I think, has a lot more real-life, real-world uses, just because the performance cost is extremely low, and it's basically the same thing as using regular point lights. As far as the player will be concerned, it just looks like some fake bounce lighting has been used here. And the only thing with this, you have to have a light probe controller in the world, or these won't work. What this basically does is this adds in the post-process volume to the world, which it won't change the look of anything in the map or the world at all. it only changes that direct spot that you place these lights. Everything will look completely normal in your environment except for wherever these lights get put at. You can get like real extreme values. Obviously that looks like crap. Just showing you kind of how it works. It's pretty neat, I think. It's definitely a system that I plan on using more extensively in the future. But the light probe controller is the main blueprint. It handles a lot of the behind the scenes stuff. It handles passing the values into the actual material parameter collection, which is again just like the global illumination system. Load that up here. The material for it will look almost exactly the same as the material for the global illumination system I had. It's basically the same in every way, except for the only difference, you're not passing a scene capture in here, you're just passing the color in through the material instead of the actual scene capture. But yeah, the actual blueprint for this, let me load that up here. So the thing about this is it is, I forget what it was called, but there's a specific type. Oh, there it is, the placed editor utility base. It's a specific type of blueprint that can tick an editor. So what that allowed me to do is have it find all of these actors in the world, and then it basically assigns them an ID number. And after assigning an ID number, it goes through to this. Well, actually, not this one. Where is it? The light function, here we go. So after assigning it an ID number, it will basically pass through the information for each loop to get the different values that are set on each of the light actors and pass that through to the function. And then it goes into the function, gets its ID number, and based on whatever ID number it is, we'll go through and set the material parameter values based on whatever ID number it comes out with. And you can see it's only going through with 6 because I must have only 6 actors in the world right now. Also, what it does, you can see it's going through 6 again because there's 6 actors in the world. And it basically zeroes out the radius for all the light parameters, the radiuses for them, so that they don't appear in the map. Like I said, it has a flat cost for the actual post-process material. So it doesn't matter if you're using 2 lights in it at a time or all 16 at a time. It will still cost the same and still deciding where to place the radiuses and lights and everything for each of the 16 points. So unless you zero out the ones that aren't being used, then they'll still render in the world. So this basically gets the last index, which is basically counting how many objects it has found. If it finds 6, then it basically zeroes out the light radiuses past 6, so 7, 8, 9, 10, and so on. So if I found like 10 points, then it would do any number above 10 would be set to 0 radius, so they don't render in the world at all. So this system kind of has to tick an editor. It does not tick in-game. It's set to only tick an editor. So its cost is still extremely cheap, even though it's ticking in editor just to kind of, it has to know where these actors are in the world, how many of them are, and then when it finds them, it will get the information on this actor, which is just the radius for it. It gets its world location so it knows where to put the point. It gets the light brightness and the fall off. And that basically, after it gets those values, like I said before, passes it into my function here and sets it all through the post-process material. And it's not that useful, but if you want to visualize just kind of the radius that this is affecting, I just set up a little simple mesh in here. So you can see about where the thing is actually affecting it. You could always just set the fall off to something like 0.1 and you'll still see the exact circle that this radius is affecting here. That's just a simple way to visualize kind of in editor. If you wanted to see for some reason the overall size of the radius by just looking at it and how much it's covering. I think that pretty much covers it. I mean, the system is built to be extremely straightforward, especially the light probe system. Like I said, if all you have to do is place the light probe controller into the world, it gets the material in and it handles ticking to figure out how many of these are in the world, giving them IDs and set up the material parameters for them. And then you literally just place light probes in the world. And you would treat them just like you do point lights for the most part. Some crazy values in there. But yeah, I'm hoping to get these systems up on the Unreal Marketplace. So I want them to be as user-friendly as possible. I think they are pretty interesting, and even though I don't think the localized one has extreme use in most gaming, I think people could still find a lot of uses for it, a lot of interesting uses for it, and I think I'll still use it. Things like scenes and stuff just to get some of the dynamic global illumination going in there. But yeah, I'm hoping to get it up on the marketplace, so it's pretty user-friendly, and again, I think people will like it because it does really give you a very nice, extremely cheap way to light your environment. Which I know a lot of people usually shy away from just using point lights. I don't think point lights are that bad in Unreal Engine 4 just because of the deferred lighting system, but it can still add up a lot, I think, going too heavy, especially on such a large, gigantic environment such as this one. You don't want like 50 point lights across the entire environment, all being rendered dynamically. Even if they're not casting shadows, it really does add up a lot. But for this one, like I said, it's just a flat cost. It doesn't matter how much of the environment it's touching. It could be touching 16, all 16 in one single area, overlapping, it doesn't matter. You could have one light affect the entire world, and it wouldn't change the actual cost at all. So you can do something like 120,000 radius. So now you're affecting everything. Again, flat cost, it doesn't matter. You could have all 16 of them affecting the entire world all at once. Wouldn't matter. It doesn't really cost any extra just because it's all done through a post-processing material. So it's pretty nice. And there is one other unique case for it, which I thought was pretty cool. Lighting translucent objects can be a bit expensive. It can cost a lot extra. But with this system, you can actually use these lights to light translucent objects without any extra cost as well. It's kind of an interesting additional bonus, you could say, from this. But since it's not just a straight up light, it's actually going to just light whatever's rendering there. So that's actually a pretty cool bonus comes out of it as well. But yeah, that's pretty much it. It is limited to 16 point lights right now, and if I do get this up on the marketplace, I hope to increase that to 32 at the very least. Maybe up to 64. It's not... I'll have to do some testing just from a performance standpoint to see if that starts affecting anything at that point. I don't believe it will, because you're not doing anything too complex. But 32 should still be no problem, so at the very least I'll update it to support at least 32 points. And right now, if you go over 16, it'll just give you a warning since it's ticking. So I just have it set up so I don't accidentally go over 16, because if you go over 16, it will break the system right now. I mean, it'll still render, but like your point light will stop having any effect. So you get this little message over here: delete some, there's too many. You delete it, it just goes away. That's just kind of a reminder to not go over that, because you might be just placing them in the world and wonder why it stops working, basically. But yeah, if I get this up on the marketplace, I'm hoping to increase the max to at least 32. It's not really a difficult thing to do. It's just basically setting up more the collection parameters, and this will basically double, if not quadruple, in size. So that's always fun. It's just a bunch of tedious work more than anything, just to scale it up. But yeah, I should be able to at least get it to 32. So that's pretty much it. I mean, this scene, this is one I've been working on for a long time. It's very work in progress, but I'm hoping to get a video up of that sometime in the next week or two. But yeah, that's it. So thanks for watching. See ya.